Hi guys, today we're going to talk about writing quadratic equations. We're going to be writing them in all three forms, so standard form, vertex form, and root form, and I'm going to show you how to do it if you're given different types of information. So the essential question is, how do we write a quadratic equations given some key features? So let's say that you're trying to write a quadratic equation and you're given roots and a point. So you're going to substitute the roots, which are r1 and r2, into root form, because that's the form that has spaces available to accept r1 and r2. So you're going to substitute r1 and r2 into the root form of the quadratic equation. And after that, substitute the given point for x and y. Now, we haven't been putting things in place of x and y except for zeros when we're trying to find intercepts, or if we found the vertex and we found the x value, we plug in whatever we got for x and we get y. But we haven't actually put a point in place for x and y, and we're going to do that because we need the a value of root form. So if I'm given roots and a point, you put in both roots, you put in the point for x and y, and then you have to solve for a because that's the only missing part of the equation. And then step 3 is to just finally write the equation with r1, r2, and the a value that you found substituted. So here's the examples. It asks you to write an equation of the quadratic function with roots of 4 and -1, and with f of 0 equaling 8. Now this is function notation, meaning that usually you have f of x, and f of x is the same thing as y, so it equals y. So 0 will be your x, 8 will be your y. If you wanted to rewrite that as an ordered pair, 0, 8 would be it. And then this is your first root, and this is your second root. And it really doesn't matter which one is root 1 and which one is root 2. You can use either one in either place. So root form is y equals a times x minus the first root and times x minus the second root. So we're going to substitute all of the things that we know. So the y value we were given was 8. The a value we do not know. We're going to leave it as a. The x value is 0, minus the first root is 4. Close parentheses, open the next, x is still 0, minus the second root, which is -1. Well, when you subtract -1, that's really like adding 1. So I'm going to go ahead and start simplifying and then solve. So I still have a. 0 times -4 is -4. 0 plus 1 is 1. If I multiply all three of these together, -4 times 1 is -4. So this is really -4a. And if I divide by -4, I get an a value of -2. So I can substitute that back into my equation. I have y equals a, which is -2, times x minus 4, times x plus 1. Remember, when you write your final root form, you want to leave x and y as variables able to receive other points. All you want to write for numbers are your roots and your a value. So go ahead and pause your video, and using number 1 as a guide, try number 2. Don't be afraid of the vocabulary word double root at 4, because what that means is that the first root is 4, but then the second root is also 4. So that's what it means when it says it has a double root. Go ahead and check your work. Your x value is 5. Your a values are -1s. Your roots are both 4, so we subtract 4 in both factors. Negative 1 minus 4 is negative 5. Negative 5 times negative 5 is 25. And in order to solve for a, you have to divide by 25. That leaves you with the fraction 5 over 25, which can be simplified, and you can rewrite it like this. Or since x minus 4 is the same for each factor, you can write it as this. So let's look at number 3. It asks you to write the equation of the quadratic pictured here. It gives you a point, so f of 0, that 0 is the x value, equals negative 12, that negative 12 is the y value. So what else do we need? We need the roots. So root 1 and root 2. Oops, there. So go look at the graph. Remember your vocabulary. Where are the roots located in a graph? They're located where the graph crosses the x-axis. So it crosses here at 1 and then 2, 3. So 1 and 3. So now that you have all of your information, go ahead and fill in and try to find the equation in root form. So check your work with mine. The a value should be negative 4. And we could also kind of see that because typically, and we've talked about vertical stretches before. We know that this graph is opening down, so the a value should be negative. And then usually to go from the vertex to the next point, you go to the right 1 and up 1, or in this case down 1 since we reflected. But that doesn't happen here. And so instead of going to the right 1 and down 1, we go to the right 1 and down 1, 2, 3, 4 until we hit the graph again. And so that's an a value of negative 4 because the graph, instead of going to the right 1 and down 1, goes to the right 1 and down 4. So it's been stretched or multiplied by negative 4. So that's my a value here. Okay, let's go ahead and move to the next page. Let's say you're trying to write a quadratic equation if you're given a vertex and a point. So not the roots in a point, but a vertex in the point. Whenever we had roots, we went ahead and substituted those roots into root form. Well, here, if we're given the vertex, what do you think we're going to substitute the vertex into? We're going to put h and k into vertex form. We're still going to be missing the a value, so we still have to substitute the x and the y in the equation so that we can solve for a. And then finally write the equation with the vertex and the a substituted, just like you've seen the last few days. So let's do the first example of this. It asks you to write the equation of the quadratic function. Here's my vertex at 3, 1, so that's the h and k value. And then it gives us another point, but remember this is function notation, so really this is f of x, negative 4 is your x value, and f of x equals y. So negative 13 is your y value. So vertex form, because we're given the vertex, that makes it easy to know we're doing vertex form. Y equals a times x minus h, that quantity is squared, plus k. Substitute your values that you know. So the y value is negative 13. A is unknown, we've got to solve for it. X is negative 4. Minus h is 3, squared, and then plus k, which is 1. All right, PEMDAS tells us to do what's in parentheses first. So inside parentheses, we have negative 4 minus 3 more. That's going to be negative 7. And exponents, negative 7 squared is 49. And now we solve our two-step equation. We move the constant. This is negative 14 equals 49a. And then we want to get rid of the coefficient, so we're going to divide by that coefficient of 49. So a equals negative 14 over 49 Both of those numbers are divisible by 7, so we're going to divide by 7 so that we can simplify this fraction. 14 divided by 7 is 2. 49 divided by 7 is 7, and that's our value. We can go ahead and plop that right into our formula along with the vertex from Vertex Form. So y equals -2/7 times x minus 3 squared plus 1. And so usually at this point some students ask, well, why can't you put x and y in there also? Well, then it would just be a number equals a whole bunch of numbers, and that really wouldn't tell us anything. So in order for us to have an equation, we have to keep x and y open and available to receive other points, rather than just -4 and -13, because many, many, many points, in fact, infinitely many points, make up this quadratic function. So looking at the example that we just did, I'd like you to pause your video and try example 5. So check your work with mine. The thing that might have happened if you did make a mistake is signs. So remember that in the formula, inside the parentheses, it's x minus h. Well, if h is already negative, when you subtract -1, what that becomes is a +1. But the k value is -6, so when you add -6, that makes -6. So these two signs are probably the most commonly incorrectly written thing if you have something that's incorrectly written in this problem. So let's move on to number 6. It says write the equation of the graph pictured below. So we have an x value, we have a y value. We probably could have picked out tons of other values for x and y from this parabola. Notice that the roots are not nice, pretty numbers. And so if I was asked to find the equation for this graph, I wouldn't use root form because I don't know the roots. I can't really tell. They're somewhere between 0 and -1, and then somewhere between -3 and -4. But I do definitely see the vertex. And that vertex is at the point -2, -2, which should be easy enough. That's my h and k value. So now, knowing what you know and having the skills that you have, go ahead and try to find the equation for number 6. All right. So notice that the a value is 3/4, and whenever I substitute that back into my equation, all I put back in is that 3/4 for a, and then the vertex, h and k. All right, last page. Let's move on. Scroll on down. Now for this one, I do need to make a little bit of a change because the site here is wrong. So it says if you're writing a quadratic equation and you're given 3 points, go to student.desmos.com. I need you to mark that out. Mark that out. Just go to desmos.com. And if you want, you can go to desmos.com/calculator. If you don't go to desmos.com/calculator and you just go to desmos.com, you can click on Graphing Calculator. It's a middle button right at the top. And typically we would use the graphing calculator in class to do these problems. But since we don't have that, we're just going to use Desmos because everybody has access to Desmos. Okay, so follow me on these because we're going to fill in the blanks so that you have the information and the steps, and then we're actually going to go do it. So the steps aren't going to make much sense to you because you can't see the screen. So step 1, go to desmos.com/calculator. Step 2 is to click the plus sign to add a table. Because remember, we're going to be given 3 points. And so those 3 x's and y's are going to get organized into a table of x's and y's. It says type the ordered pairs into the table under x1 and y1. That's what the columns will be labeled. And under the table, use this symbol on your keyboard to type this equation. Now, it looks very much like standard form, except we've got y1 instead of y. We have x1 here and x1 here instead of x. And then we have this little kind of squiggle here instead of the equal sign. So Desmos recognizes this as pulling your your y1 values and your x1 values from the table. So that's how Desmos knows to pull those values to create your equation. The 1s here for the y's and the x's will automatically become subscript, so it'll be like y sub 1s and x sub 1s, which is what you want. And then finally, you'll write your equation by substituting the given values of a, b, and c from Desmos into standard form. So let's try this out. Okay. There we go. Okay. So we have example 7, and I'm reading from the notes. I know that it's not on the screen, but we have example 7 that says -5, 2, -2, 7, and 0, -3. Our instructions are to write an equation for the quadratic function. So what I'm going to do is follow my steps. We are at we're at desmos.com/calculator. We're going to type the plus sign, tap the plus sign right here. You're going to add a table. Notice that it's labeled X1 and Y1. Your color might be different, but that's okay. We're going to enter our points into our table. So the first point was -5, 2. So -5 and 2. The next point is -2 and 7. -2 and 7. And the last point is 0 and -3. So you have all 3 of your points entered. Under the table, there's a place for you to type a new equation or put a new item. And under that, you're going to use the little squiggle sign, which happens to be on your keyboard to the left of the number 1. So you're going to type y1, and instead of an equal sign, your little squiggle. And it equals a times x1 squared. Remember, to do an exponent, you type the caret. And then plus b times x1. So instead of bx, it's plus b x sub 1. And then plus your constant, c. Notice how on your graph you have your points here, here, and here from your original set of points. We also have our roots that are not nice pretty numbers, but they are there. And then we also have our vertex that we can pick out. But notice how the quadratic, the parabola, goes through all 3 of our points. So now I'm going to take my A, B, and C values, and I'm going to substitute those into my standard form, rounding to the nearest 3 decimal places, so thousandths. So I'm going to go ahead and write, and then I'll take this off of my screen. Y equals -1.333x squared minus 7.667x minus 3. Okay. So now that you have the idea, pause your video, use the first example that we did together, and try number 8. So you'll notice on number 8 that once you type in the new values in your table, your A, B, and C value here automatically change. So when you write your equation, this is what you get. So the last problem is a word problem, and it says Lucy launched a ball into the air using a tennis ball launcher for her dog, Bobby. She wants to know the equation of the path of the ball. So whenever you throw a ball, if you throw it up, it must come back down, right? So what shape is that? That's a parabola. So we say this tennis ball has parabolic shape. She knows that it went through the points 1, 60, 3, 60, and she also knows that 2, 80 is the highest point. So if that's the highest point, that would be the vertex. Help her find the equation so that her dog Bobby can find the ball. So if you are given 3 points, you can use Desmos and its calculator to figure out the equation. So pause your video and try it out. Now when you type in your new points to your table, you'll notice that A is -20 and B is 80, which is great, but the C value is something a little strange. Remember that that looks like scientific notation. So when you have something times 10 to the power of negative and then it's a big number, that means that the decimal moves from where it is to the left 14 times. So that's a really, really, really small number. So we're going to consider that so small that it's 0. And so we have y equals -20x squared plus 80x plus 0.